Welcome to the third episode of our Networking for Cybersecurity series. Now picture this that you open your browser, type google.com and within milliseconds the website appears. Behind this seamless experience lies a powerful network infrastructure working tirelessly. Ever wondered how it all connects? In today's episode, we will break down critical components like DNS, that is Domain Name System, and DHCP, that is Dynamic Host Configuration Protocol. Ready to dive into the digital backbone of networking? Let's go. The DNS, that is Domain Name System, is a hierarchical and distributed naming system that converts domain names like google.com into IP addresses. Think of DNS as a phone book. When you want to call someone, you search for their names to find their phone numbers. Similarly, when you type a website's name, DNS finds its IP address and connects you. Without DNS, humans would need to remember complex numerical IP addresses to access websites, which would be completely impractical. DNS operates through a step-by-step process that resolves human-friendly domain names into machine-readable IP addresses. Here's an easy-to-follow explanation of the process. Step 1. Reader enters a domain name. When you type a URL like www.example.com into your browser, your device sends a query to resolve this domain name into its corresponding IP address. Step 2. Query checks local cache. First, your browser checks its local DNS cache to see if it is already knows the IP address for the domain. If it doesn't, the query moves to the next step. Step 3. Recursive DNS resolver. The query is sent to a recursive DNS resolver, usually managed by your ISP, that is Internet Service Provider, or a public DNS service like Google DNS. This resolver takes responsibility for finding the IP address by contacting other DNS servers. Step 4. Root DNS server. The recursive resolver first contacts the root DNS server. So, root servers are the top of the DNS hierarchy. They don't store specific domain information but direct the query to the relevant top level domain, that is TLD servers. Step 5. TLD DNS server. The root server points the resolver to appropriate TLD DNS server. TLD servers handles information about domains within their specific extensions. For example, the .com TLD server knows where to find authoritative information for all .com domains. Step 6. Authoritative name server. The TLD server directs the query to the domain's authoritative name server. This server holds the actual IP address for the requested domain. For example, it stores the mapping that says www.example.com corresponds to 93.184.216.34. Step 7. Response sent back. The authoritative name server sends the IP address back to the recursive resolver. The recursive resolver stores this information temporarily in its cache and forwards it to the device. Step 8. Connection established. Your browser uses the IP address to establish a connection to the website server, and the requested web page loads. You can take an example like imagine looking for a friend's house in a large city. Their root server is the city guide who tells you which neighborhood, that is TLD, your friends live in. TLD server is the neighborhood map that directs you to the specific street, like authoritative name server. Dynamic Host Configuration Protocol, that is DHCP, automates the assignment of IP addresses, subnet masks, default gateways, and DNS servers to devices in a network. This eliminates the need for manual configuration, ensuring smooth onboarding of devices. Imagine walking into a hotel. Instead of assigning rooms manually, the hotel uses a system that automatically allocates you a vacant room. Similarly, DHCP dynamically allocates an IP address from its IP address pool. The DHCP process involves 4 steps, often referred as DORA. First step is discover, which includes the client broadcasting a request to locate a DHCP server. Second step is offer. In this, the DHCP server responds with an available IP address and configuration details. Third step is request. The client requests the offered IP address. And the last step is acknowledge. The DHCP server confirms and assigns the IP address. DHCP can be configured with leech times, ensuring IPs are reclaimed if devices leave the network. In the next episode of this series, we will go through the firewalls and subnetting. So if you enjoyed this breakdown, don't forget to like, subscribe and share. Your support helps us bring more engaging content to you. See you in the next episode of our networking series.